Hello everybody and welcome. In today's video we're going to be finding the inverse of matrices and we're going to be going over 4 examples of those. So without further ado, let's get it. So before we begin going over the example problems, let's just quickly look at what an inverse matrix is. Basically what this is telling us is that if you were to multiply matrix A by its inverse, what you're going to get is the identity matrix here, which looks like that. And all that is when you have ones across the diagonals and zeros everywhere else. And the one thing that we should note is that this will only work for square matrices, so like 2 by 2 or 3 by 3, so on and so forth. That's what this n represents right here. Um, and then the other thing to note is that the order when you multiply is not going to matter. So if you multiply the inverse, if your matrix, the inverse matrix is on the first matrix, and then you multiply it by matrix A, then you're going to get the identity matrix as well. Okay, so with that being said, let's go on to the first example. Example number 1. We're going to find the inverse of this matrix by using the Gauss-Jordan method. So what we want to do when using this method is where your matrix is adjacent to it, you're going to write the identity matrix, which is 1, 0, 0, 1. Okay, so this is the identity matrix. And what you want to do is pretty much transform the left-hand side to become the identity matrix. All right, by using the row operations that we've learned in the past. So we want this left-hand side to be the identity, and then whatever you get on the right-hand side after you make the left-hand side the identity matrix is going to be your inverse. Okay, so let's go ahead and get started. So first things first, I want the left-hand side to be the identity matrix. That means I need to get rid of this 2. I need to make that 2 on the bottom there a 0. All right, and the way we're going to do that is by multiplying row 1 by -2, so -2 times row 1, and then we're going to add that to row 2. Okay, and by doing that, what we're going to get is 1, -1, 1, 0, and then we get -2 times 1. We're looking up here, so -2 times 1 is -2, plus 2 is 0. Over here, multiply that by -2, so -2 times -1 is +2, minus 1 is 1. All right, and then we also have to do it to the identity side there. So -2 times 1 plus 0 is -2, and then -2 times 0 plus 1 is 1. All right, so that's our first one right there. Now what we want is to make this number here become a 0. So the way we're going to do that is by adding row 2 plus row 1. So we have row 2 plus row 1, and that is going to look like this. So row 2 stays the same, 0, 1, -2, 1. And then when we add them together, we're looking up here. 0 plus 1 is 1. 1 minus 1 is 0. -2 plus 1 is -1. And then 1 plus 0 is 1. All right, so now what we can see is our left side here is our identity matrix, which is what we wanted. And that means the right side here is our inverse matrix. Okay, so let's go ahead and just write this down one more time. -1, 1, -2, 1. This right here is our inverse matrix, and this example is complete. Example number 2. So we want to find the inverse using the Gauss-Jordan method on this 3 by 3 here. So whenever we want to start, we want to write our identity matrix on the right-hand side, which is what I did here. And then what we want to do is make the left-hand side the identity matrix, and then the right-hand side will become the inverse. Okay, so first things first, we want to make the left-hand side the identity matrix. So that means that I need to get this 1 here and this 6 here to become a 0. All right, let's start with the 1 here. The way I'm going to make that a 0 is I am just going to multiply row 1 by -1 and add it to row 2. That'll make that a 0. So we got negative row 1 plus row 2. That's going to clear out the 1. Now, to clear out this 6, all we have to do is multiply row 1 by -6. So -6 row 1 plus row 3. All right, and I'm going to do it in 2 steps here just to, or do 2 steps in one just to save some space. So when we do that, row 1 is going to stay the same. So we have 1, -1, 0, and then our identity side, 1, 0, 0. All right, and now let's go ahead and start with the first operation here, negative row 1 plus row 2. So we're looking at these 2 columns here, or those 2 rows, I should say. So -1 times row 1 plus row 2. So -1 plus 1 is going to be 0. -1 times -1 is +1, plus 0 is 1. And then 0 times -1 is 0, minus 1 is -1. And then we also have to do it to the right-hand side. So look in here, -1 times 1 is -1, plus 0 is -1, and then we will get 1 and 0. All right, so now let's look at the second operation here, and we're focusing on eliminating that 6. So we got -6 times row 1. So -6 times 1 is -6, plus 6 is 0. And then we have -6 times -1 is +6, plus -2 is 4. -6 times 0 is 0, minus 3. -6 times 1 is -6, and then plus 0 is -6, and then we will get 0 and 1. All right, so next off, what we want to do is get rid of this 4 here, make that a 0. And the way we're going to do that is by multiplying row 2 by -4 and adding it to row 3. So -4 row 2 plus row 3, like that. And when we do that, row 1 is going to stay the same. 1, -1, 0, 1, 0, 0. Row 2 is going to change. Row 2 is going to stay the same. 0, 1, -1, -1, 1, 0. And now row 3 is going to change since we're multiplying -4 to row 2 and adding it to row 3. So looking at our matrix up here, so right over here, multiplying that number by -4 and adding it, so that's going to be 0, 0. -4 times -1 is +4, minus 3 is 1. -4 times -1 is +4, minus 6 is -2. -4 times 1 is -4, plus 0 is -4. And then you got 0 plus 1 is 1. All right, so that's that part. Now, when we're looking at this, we want to make this right here a 0. And all we have to do is add row 3 to row 2. So our operation is row 3 plus row 2, like that. When we do that, row 3 stays the same. 0, 0, 1, -2, -4, and 1. All right, and now when we add these together, what do we get? We will get 0, 1, 0, -3, -3, and 1. All right, and all I did was just add row 3 and row 2 together, which are these two right here. We just added those. Okay, row 1 is going to stay the same, so let's go ahead and write that down. 1, negative 1, 0, 1, 0, 0. All right, last, what we want to do is get rid of that negative 1 up there. And the way we're going to do that is by adding row 2 to row 1. So our operation is row 2 plus row 1. Okay, and row 3 is going to stay the same. So 0, 0, 1, negative 2, negative 4, and 1. Row 2 is also going to stay the same. 0, 1, 0, negative 3, negative 3, and 1. And all we're doing is just adding these two rows here together. All right, so we're going to get 1, 0, 0, negative 2, negative 3, and 1. All right, so we got what we wanted. The left-hand side is our identity side. The right-hand side is our inverse. So let's just write this down one more time. Negative 2, negative 3, 1, negative 3, negative 3, 1, negative 2, negative 4, and 1. That right there is our inverse matrix. Therefore, this example is complete. Example number 3. In this example, what we want to do is find the inverse using what's called the determinant. So the determinant is this bottom piece right here, AD minus BC. That is what's called your determinant. And one thing to note is that this formula right here is only going to work for 2 by 2 matrices. Okay, so if you have a 3 by 3, you can go ahead and use that Gauss-Jordan method that we went to, or anything greater. So what this formula right here is basically saying is that if you have some arbitrary matrix, call it matrix A, right, and its corresponding numbers are going to be A, B, C, and D, to find our inverse, all we have to do is multiply 1 over the determinant times this new matrix here, where all we do is actually just swap A and D's places and change the signs of the other two numbers. So looking at our arbitrary matrix here, all we do is we swap places of these two terms right here, and then we change the sign of the other two, like that. Okay, and that's how you get that matrix on the right side of 1 over the determinant that we're going to multiply by. Okay, so it's a little confusing when you're first staring at it. So let's go over this example problem and clear that up. So what you want to do first is check your determinant, because if that is equal to 0, that means there's no inverse. So let's go ahead and do that over here. So AD minus BC. Okay, so A is the number on the top left, which is 1. D is the number on the bottom right, which is negative 1. And we're going to subtract that by B, which is the number on the top right, negative 1. And then that is multiplied by C, which is the number on the bottom left, which is 2. Right? And these numbers right here, you get it from there. That's how we got those numbers. So those are where the locations are, and then we use the matrix that we're given to find the actual numbers that we're going to be using. All right, so what we're doing here is checking to see if this AD minus BC is 0 or the determinant is 0. So 1 times negative 1 is negative 1 minus negative 1 times 2 is negative 2. This becomes negative 1 plus 2, which is equal to 1. So our determinant is not 0. That means we know we have an inverse. All right, so now let's go ahead and write our problem. So the inverse is equal to 1 over the determinant, which we found was 1, this number here, times our matrix, which now what we do is we swap the spots of A and D, which is these two right here that are circled. So we're going to switch those spots. So -1 is on top and +1 is on the bottom. And now what we do to find B and C is we just change the signs. So this 1 is going to be a +1, and this 2 is going to be a -2. All right, so that's going to be 1 and -2. All right, continuing on, the inverse is going to be equal to 1 times our matrix, which is -1, 1, -2, 1, like that. And you have to distribute this number on the outside to everything within the matrix. In this case, it's 1, so everything's going to stay the same. However, if it was a different number, you have to multiply it to every number inside. All right, so now what we know is that our matrix here, the inverse is -1, 1, -2, and 1. Okay, so we found our inverse here. Therefore, this example is complete. And I just want to show you one thing real quick. So we already found the inverse of this matrix before, and that was over here in example number 1. And as you can see, we have the same exact answer. So both methods are going to work. However, if you have a 2 by 2, then you can use the determinant method. All right, so let's go on to the next one. Example number 4, we want to find the inverse using the determinant method that we just went over. So let's go ahead and do that. And what we want to do is multiply 1 over our determinant, which is AD minus BC, multiplied by DA negative BC, negative C, like that. So let's go ahead and find our determinant first. So we're going to have 1 over A times D, which is 3 times 2, subtracted by -1 times -6. And then our matrix is going to be 2, 3, 1, and 6, like that. So now let's go ahead and continue here. So we're going to have 1 over 6 minus 6, which is going to give us 0. Okay, so this right here is going to be our stopping point. Whenever your determinant is equal to 0, that means there is no inverse for that matrix right there. Okay, so what you could do is you could just start off by finding your determinant and then checking to see if it's equal to 0. If it's equal to 0, there's going to be no inverse, and then you won't be able to proceed. So that's how you determine if a 2 by 2 matrix will have an inverse or not. In the Gauss-Jordan method, your math is simply just not going to work out. You're never going to get the identity matrix on the left-hand side, which is where you want it. Whenever you're finding determinants or using the determinant method, if your determinant is equal to 0, there's not going to be an inverse. So this example is complete.